Step outside just before sunrise, the world feels transformed. Familiar streets fade into soft silhouettes, trees dissolve into pale shapes. Light bends and scatters, turning car headlights into glowing orbs suspended in white air. Sound becomes muted, as if wrapped in cotton. It feels almost otherworldly, as though the sky itself has lowered and settled onto the ground. This is fog, a cloud born at the surface of the earth. At first glance, fog seems mysterious. It appears suddenly, hides landscapes, then vanishes without a trace. But behind this quiet phenomenon lies a precise balance of temperature, moisture, and atmospheric physics that operates continuously around us. To understand fog, we must begin with something invisible: water vapor. The air around you always contains water in gaseous form. Even on a perfectly clear day, countless water molecules drift unseen through the atmosphere. The amount of water vapor air can hold depends strongly on temperature. Warm air can hold a large amount of moisture. Cold air can hold much less. This relationship is crucial. As air cools, its capacity to hold water vapor decreases. If the temperature drops to a specific point called the dew point, the air becomes saturated. At this stage, it cannot hold all its moisture in invisible form. The excess water vapor begins to condense into tiny liquid droplets. Condensation does not happen spontaneously. Water vapor needs microscopic particles to cling to: dust, salt from ocean spray, smoke, pollen, or even pollution. These tiny particles act as condensation nuclei. When water vapor gathers around them, microscopic droplets form. When billions of these droplets accumulate near the ground, they scatter light in all directions. Visibility drops, the landscape blurs, fog forms. In essence, fog is simply a cloud that touches the ground. But how does the air near the surface cool enough to reach the dew point? There are several mechanisms. One of the most common is radiation fog. This typically forms on clear, calm nights. During the day, the Earth's surface absorbs solar energy. At night, especially when skies are cloudless, the ground radiates heat back into space. Without cloud cover to trap warmth, the surface cools rapidly. The air directly above it cools as well. If this cooling continues until the air temperature meets the dew point, condensation begins near the ground. By early morning, a layer of fog may blanket fields, roads, and valleys. When the sun rises and warms the surface again, the fog often evaporates and disappears. This explains why fog is so common in the early morning hours. Another major type is advection fog. This occurs when warm, moist air moves horizontally over a colder surface. For example, when humid air flows from a warm ocean current over cooler coastal waters, the lower layer of air cools rapidly. If it reaches the dew point, fog develops over the sea and can drift inland. Coastal cities often experience thick sea fog for this reason. The dramatic fog in places like San Francisco forms when moist Pacific air encounters cold ocean currents and cool land surfaces. Upslope fog forms in a different way. When moist air is pushed upward along hills or mountain slopes, it expands and cools as pressure decreases with altitude. If the air cools enough during this ascent, condensation occurs and fog forms along the slope. In mountainous regions, this can create misty landscapes that seem to emerge from nowhere. There is also evaporation fog, sometimes called steam fog. This happens when cold air moves over warmer water. The water evaporates into the cold air just above the surface. If the added moisture quickly reaches saturation, fog forms in thin wisps, rising from lakes or rivers, especially on chilly mornings. Though fog appears thick and heavy, its droplets are incredibly small, much smaller than raindrops. These droplets are so tiny that they remain suspended in the air rather than falling. That is why fog feels like fine mist on your skin rather than rainfall. Fog can vary greatly in density. Light fog may only slightly reduce visibility, while dense fog can reduce it to just a few meters. This can create serious challenges for transportation. Drivers, pilots, and ship captains must rely on instruments when visibility drops. Entire airports can shut down because of thick fog. Yet fog is not only a hazard. In some ecosystems, it is a life source. In certain deserts, such as along the coasts of Chile and Namibia, rainfall is rare, but fog drifts inland from the ocean, bringing moisture. Specialized plants capture water droplets directly from the air, allowing life to survive in otherwise dry landscapes. Fog also influences local temperature. By reflecting sunlight during the day, it can keep regions cooler. At night, it can act like a blanket, trapping heat near the surface and preventing temperatures from dropping too quickly. The difference between fog and dew is subtle but important. When water vapor condenses directly onto surfaces like grass or leaves, it forms dew. When condensation occurs in the air itself, creating suspended droplets, it forms fog. From a scientific perspective, fog represents a moment of equilibrium. The air has cooled to the exact temperature where invisible vapor becomes visible liquid. It is the point where the atmosphere reveals the moisture it has been holding all along. What makes fog so captivating is not just its science, but its transformation of space. It softens edges, diffuses light, and creates depth illusions. Familiar places become dreamlike. Distance disappears. The world feels smaller and quieter. And yet, behind this beauty lies a simple process. Cooling air reaching saturation, water vapor condensing into droplets, light scattering through suspended moisture. The next time you walk through fog, you are literally walking inside a cloud. Around you float billions of microscopic droplets, each formed from water that may have evaporated from oceans, rivers, or soil days earlier. They hover in the delicate balance between liquid and vapor, waiting for temperature and sunlight to shift again. Fog reminds us that the atmosphere is never empty. Even when the sky appears clear, it is filled with invisible moisture, energy, and motion. Under the right conditions, that hidden water reveals itself, turning air into something you can see, feel, and move through. It is not magic. It is physics made visible, a quiet demonstration of how temperature, pressure, and water shape the world around us.